We've sent these incredible rovers to Mars, we've flown probes past Pluto. So why? Why haven't we been back to our closest cosmic neighbor in over half a century? It almost feels like a glitch in the matrix of progress, right? Let's get into it. I mean, it's a genuine paradox when you think about it. We've gotten so good at remote exploration, basically dropping these robotic geologists on other planets. So, why is the moon, a place we've actually been to, been off limits for human hands for so long? What was the holdup? 52 years. Just let that number sink in for a second. The last time a human being left a footprint on the moon was way back in December 1972. To really understand why this long pause happened, we've got to rewind and look at how that first incredible chapter of moon exploration actually ended. Okay, so let's talk about Apollo. No question, it was one of humanity's greatest achievements ever. But, and this is a big but, it was also a product of its time. It was this magnificent, breathtaking sprint that was just never, ever designed to be a marathon. In a way, it was a dead end by design. And you know what's wild? The program went out on its absolute highest note. Apollo 17. Man, it was a masterpiece. For the first time, they had a professional geologist, Harrison Schmitt, right there on the crew. They drove the rover over 35 kilometers. That's a long way. And found this now iconic orange volcanic glass that was, get this, 3.5 billion years old. It was truly the peak. But here's the catch. This is the crucial point. Apollo was built for one reason and one reason only: to win a political race and to do it fast. The cost was staggering, over $170 billion in today's money. And what was the long-term legacy of all that cash? Basically, a bunch of discarded hardware and zero reusable technology. It was absolutely stunning, but it was built to be a one-and-done deal. In this moment, it just says it all. Gene Cernan, the last man to walk on the moon, climbs up that ladder, and he doesn't promise to come back. Because in their minds, the job was done. The race was won. That's it. But here's the thing. Even if we had wanted to go right back, we were about to find out that the moon itself is a far more dangerous place than we realized.
So this is where the real challenge comes in. See, the Apollo astronauts, they were just tourists, really. They stayed for a couple of days, max. But to actually live there, well, that means facing an environment that is just relentlessly hostile. It's full of these silent killers that are constantly trying to break down everything, both technology and human life. First up, the dust. And I'm not talking about beach sand here. This stuff, called regolith, is basically microscopic, razor-sharp shards of glass. Yeah, it's like billions of tiny daggers. During the Apollo missions, it got into everything. It jammed zippers, it was literally sanding away the layers on their spacesuits, and it even gave the astronauts what they called lunar hay fever. It's this relentless, grinding threat.
And then there's the stuff you can't even see: radiation. Here on Earth, we're lucky. We're protected by this big magnetic field, like a planetary force field. The moon, it has nothing, no shield. So the surface is just constantly getting blasted with cosmic radiation. We're talking levels up to 200 times higher than here. A short trip is one thing, but trying to live there long term, that's a huge biological risk. Okay, and if that wasn't enough, let's talk temperature. A single day-night cycle on the moon lasts almost a whole Earth month. So picture this. You get 2 straight weeks of scorching heat, over 120 degrees Celsius, way hotter than boiling water. Then it's followed by 2 weeks of a deep freeze, below minus 170 Celsius. Trying to engineer anything to survive that kind of insane swing is just an enormous challenge. So you've got this incredibly deadly place for humans. How in the world do you explore it? How do you even begin to prepare for a return? Well, you send in a team that doesn't need to breathe, isn't afraid of radiation, and couldn't care less about the dark. You send in the robots. And honestly, the logic here is just undeniable. A robot doesn't need oxygen, it's not vulnerable to radiation like we are, and it can just patiently keep working for years, even decades. They can do all the dangerous, boring, tedious work, the mapping, the analysis, the testing, all for a tiny fraction of the cost and with zero human risk. They became our eyes and hands on the moon. And that's exactly what happened for decades. This so-called gap wasn't a gap at all. It was this quiet, global campaign of robotic reconnaissance. You had missions from the US, from China, from India, all of them acting like these persistent detectives, meticulously mapping every crater, measuring the radiation, and searching for the clues that would finally let us come back safely.
And what these robotic detectives found? Well, it didn't just pave the way for us to return. It gave us a whole new, incredibly compelling reason to go back. They found the one thing that completely changes the game for space exploration. Water. Yep, water ice. The robots confirmed that huge amounts of it are just sitting there, locked away in craters at the lunar poles that have been in shadow for billions of years. This discovery, this was the turning point, because in the vacuum of space, water isn't just for drinking. It is pure liquid gold. So why is it liquid gold? It comes down to some really beautiful, simple chemistry. You can take that water ice, zap it with solar power, and split it right into its basic parts, hydrogen and oxygen. And what are hydrogen and oxygen? Well, they're the two main components of rocket fuel. All of a sudden, the moon isn't just a destination anymore. It's a gas station in the sky. This one discovery just fundamentally changed the entire strategy. It sparked a brand new program, one designed from the ground up not to repeat Apollo's short sprint, but to build something that lasts. And that program is Artemis. And this really shows you the total shift in thinking. If Apollo was a political sprint just to plant a flag, Artemis is a scientific marathon to actually build a base. The whole model has changed. It's not a national race anymore. It's a global partnership. We're not using disposable tech. We're building reusable systems. And maybe most important of all, the moon isn't the end goal this time. It's the first stepping stone to Mars. Yeah, the whole plan is built around sustainability. It relies on partners, both international agencies and private companies, to share the costs and the brainpower. It's got this orbiting space station called the Lunar Gateway that'll act as a sort of hub, and it totally integrates robots as part of the team, sending them ahead to scout and set things up before any astronaut's boot hits the ground. So here's the real takeaway. That 52-year wait, it wasn't an empty gap. It wasn't a failure. It was a necessary strategic pause. It was the time we needed to do the science, to build the right tools, and to find the resources that would let us go back, not just to visit, but this time to stay. We were quietly learning how to turn the moon from a dusty monument into a launch pad for the rest of the solar system. And that's why we're going back. Ultimately, it's not even just about the moon anymore. It's about learning how to live, how to build, and how to thrive off-world. It's our dress rehearsal for Mars. It's about taking that first real step toward becoming an interplanetary species. So yeah, the long, long wait is finally over. But the real journey, it's just getting started.